In section 8.5, we're going to start working on factoring quadratic functions. And we're going to start with the easiest functions, and those are the functions with a leading coefficient of 1. So we're going to be working on factoring trinomials with a leading coefficient of 1. And our key vocabulary is, what is the zero of a function? So we're going to go through that as we proceed through. So let's take a look at the idea of factoring from this form where our leading coefficient is 1. So there's a 1 right here. And the reason the 1 isn't, it makes it easier is that I don't have to account for as many different possibilities of my firsts. And when you think about FOIL, we're really talking about, if I sort of put this together, let's say C plus D. These are numbers. Okay, so if I have a binomial that I'm multiplying together, you know with FOIL I'm going to do the first, which is A times C, and then I'll have my outsides, which would be A times D, and then my insides, which is going to be B times C, and then my last, which is B times D. And we know that this makes a term, it's going to make this first term, right? And when I just have x and x, when my leading coefficient is 1, every single time it's x squared, so it's x and x. It happens every single time. And then this final term is made there. And what we're doing when we're factoring is we're checking the different possible things that could make this first term and the different possible lasts, so the different firsts and the different lasts, and how those firsts and lasts create an outside and inside that is going to make this middle item. Okay, so if we take a look at this example, they have x squared plus 5x plus 6. I know that my firsts were x and x. I can see here that I have a 6 that's positive, and the way I'd get a positive 6 would either be a negative times a negative, which makes a positive, or a positive times a positive. But when those two items were added together, they became positive, so I know that they're both positive, plus and plus. And now I want to find the factors of 6 that will add up to be 5. Well, the factors of 6 are 1 and 6, and 2 and 3, and 1 and 6 add up to be 7. 2 and 3 add up to be 5. So I'm using 2 and 3. Okay, so we're testing. In this case, all I have to worry about are the way the lasts worked out, because the firsts both involve the coefficient of 1, and that doesn't alter the lasts at all, so I can focus just on the lasts. It makes it a little simpler. So let's do another one. When B and C are positive, right? Again, I always know what's happening by looking at the signs. I know what's happening in my binomials by looking at the signs. And when I have a plus here before the last term, I know that the signs in the binomials are the same, because it has to be either negative times negative or positive times positive. And then this sign will tell me what they are, so I know that they're plus and plus. I know that a squared is made by multiplying a times a, and then I want factors of 8 that will add up to be 6. Well, my factors of 8 are 1 and 8, which adds up to be 9. I've got 2 and 4, and that adds up to be 6. That's what I wanted, so I put 2 and 4. And I'm factored. Now this is still very, very similar, what we're going to do here, because I know that the signs in my binomials are the same, but I know that they're both negative because of this. So because a negative number times a negative number will give a positive result as well, but when I add the two numbers together, they're negative, so they must both be negative numbers. I know that b squared was made by b times b, and then I want factors of 72 that will combine up to be 17. Okay, so factors of 72 that add up to be 17. So I know that I've got 1 and 72. That adds up to be 73. That's not going to help me. I know that I've got 2 and 36. That adds up to be 38. I have 3 and 24. Those add up to be 27. I've got 4, and 4 goes into that 18 times. And that adds up to be 22. I have 6 and 12. That adds up to be 18. And I have 8 times 9, and that adds up to be 17. Okay, great. So I tested a number of different possibilities, but I found the right one. So it's going to be 8 and 9. Okay, if I want to ever test these, I can just multiply them out. I'll have b times b is b squared. I'll have b times negative 9 is minus 9b. I'll have negative 8 times b, that's negative 8b. And negative 8 times negative 9 is positive 72. And see, this is what we were testing. This middle term becomes negative 17b. So if I can take my factored binomials and multiply them together and go back to the original equation, I know that I've done it correctly. Okay, let's look at another situation here. Okay, so now when c is negative, when my constant is negative, that's made by multiplying a positive number times a negative number. There's no other way to do that, right? So I know that one of these is plus and one of them is minus. And because when combined, this came out to be plus, I know that the bigger one has to be a positive number. I still know that x times x makes x squared, so I can put those in. And now I want factors of 72 that have a difference of 6. So if you remember, if we go back to the ones we were doing, 72 and 1, 72 minus 1 is 71. I had 36 and 2, difference is 34. I had 3 and 24, I'm sorry, I'm writing it upside down. 24 and 3, the difference is 21. I have 12 and 6. Sorry, I skipped one. I had 4 and I had 4 and 18. The difference there is 14, but 12 and 6, the difference is 6. That's the one I want. And remember, the bigger number goes here, 12 and 6. So what I'm going to get for my outsides and insides, I'll get negative 6x plus 12x will combine to be plus 6x. Okay, and this is a very similar case. I've got the minus sign here at the end, which means that one is a plus and one is a minus. I know that m times m makes m squared. And I want factors of 120 that have a difference of 7, but now you see it becomes negative 7, so the bigger number has to go with the minus sign. So 120 with a difference of 7. Oh, good question. So that's, I'm going to try to be as close as I can without, I'm not going to try them all. For instance, I'm not trying 120 and 1. I always want you to think of that, but so 20 and 6. Okay. So if I take a 2 out of here and I multiply it times the 6, then I'd have 12 and 10, but those have a difference of 2. I could have 15 and 8. Those have a difference of 7. Okay, and if you're concerned about how to do the factoring of the constant, you could always do a prime factorization and then you can use those in a lot of different ways to find these different factors. Okay, remember the bigger of these two, 15 and 8, has to go here. So the 15's there and the 8 goes there. Okay, so that covers all the different possible situations. Positive, 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 negative. Negative, positive, negative, negative. Those are all the different ways it can come out. And this is how you determine how to factor it and what pieces go where. When we take this extra step and want to solve, we're looking for zeros of the polynomial. So if you remember, the zero of a function, the solutions of our polynomials are always a value of the polynomial, value of x that will create an output of y. So we're really looking at zeros. That's why we call them zeros. They're values of x that have an output of 0. And in this case, you can see this is a little problematic because I have a negative leading coefficient, and that makes things a little difficult. When I have a negative leading coefficient, I'm just going to factor a negative 1 out of everything. So then this negative x becomes x squared, 16x becomes minus 16x, and minus 28 becomes plus 28. And now I can go ahead and factor. I know that my signs are both the same, and they're both going to be minuses. So I'm going to have x minus something and x minus something. Okay, I know that x times x makes x squared. And I want factors of 28 that add up to be 16. Well, I think 2 and 14 add up to be 16, right? 14 and 2. And it doesn't matter where I put them because they're both going to come out minus. And that's what makes the minus 16. Now, if I multiply three things together and the result, the product is 0, that means that one of these three things had to equal 0. So the negative 1 is never going to equal 0. It has no bearing on the solutions. And if I take each of these binomials and I set them to be equal to 0, I'll get x is equal to 14. And when I set x minus 2 to be equal to 0, I get x is equal to 2. And these are my zeros. They're also what we would call solutions. They're also what we would call roots. And they're also the x-intercepts of this quadratic function. Okay, so when the book is asking you to find zeros, or asking you to find solutions, or asking you to find x-intercepts or roots, they're asking for the same things. Okay, if we go ahead and do this problem, we're going to do the same sort of thing. We're going to make it equal 0. I don't have to worry about a negative leading coefficient, but I know that my signs are the same, and they're both going to be minus signs again. I know that x times x makes x squared, so it's going to be x minus and x minus. And I want factors of 32 that add up to be 18. Well, 16 and 2 add up to be 18. So I've got 16 and 2. So my solutions are going to be x is equal to 16, because 16 minus 16 is 0, or x is equal to 2. Okay, those are my solutions. If we take a look at this in a real-world kind of context, if we take a look at these guys, we're going to be making these banners. So we're making banners to hang in the school during Spirit Week. And each banner has 16.5 square feet of felt, and they're cutting them like this. And you can see that these are both the same shape. And in fact, if I rotate them, I can put them together to make one big long rectangle. Okay, and if you remember what the sizes were, this is W, this is W, this is 4. So when we start looking at the area of the fabric that we have, we could see that we've got this plus this plus this. So we've got these two rectangles, and we've got a square. Okay, so if I wanted to look at the area, I know that the area is going to be 4 times W, and this one's going to be 4 times W, and this one's going to be W squared. Right, so I haven't really written this 100% in the right way. As I bring it down here, I'm going to incorporate this information that since each banner was 16.5 square feet, that means together, as I've drawn them out, it's 33 square feet. So I know that 33 square feet, right, so that's going to be feet squared, is equal to W squared plus 8W. So I combine like terms, and I also put my polynomial in the right order. So now if I wanted to set this to be equal to 0, I give 0 is equal to W squared plus 8W minus 33. Okay, and then I'm going to look for factors of 33 that have a difference of 8. And I also know that I'm going to have plus times minus. I know that W squared is made by W times W, and one's going to be a plus, one's going to be a minus, and the bigger one has to be plus, so the bigger one has to go there. Factors of 33 with a difference of 8 are 3 and 11, right? 11 and 3 make 33, and when I subtract them, they have a difference of 8. So the bigger number, 11, goes here, and 3 goes there. Now, when we look at this, I can say then W is going to be equal to negative 11, or W is going to be equal to 3. Well, can I have a negative amount of a banner? No, I can't. So the answer is W is 3. Okay? And that's working with quadratic functions with a leading coefficient of 1.